Hello everyone, I am Dhanamalia from the Department of Artificial Intelligence and Data Science. Today I am going to present my project titled An Intelligent System for Brain Tumor Classification using MRI Scans. This project was developed under the guidance of E.T. Jabba Jasmine Mama. This project is developed to use deep learning and explainable AI for accurate and early brain tumor detection. Agenda. In this presentation, I will cover introduction, problem statement, scope of the project, methodology, architecture, algorithms used, implementation, output, results, conclusion, and future work. Introduction. Brain tumor or critical neurological disorder caused by abnormal cell growth in the brain and can be life-threatening if not detected early. MRI scans are commonly used for diagnosis, but manual analysis is time-consuming and depends heavily on expert radiologists. With advancement in AI and deep learning, automated brain tumor classification system can accurately analyze MRI scans, identify tumor types, and assist in early diagnosis by reducing human error. Statement of the problem. The main challenge in brain tumor detection using MRI scan is that it requires expert radiological analysis, which is time consuming and may lead to subjective error. Early stage tumors are difficult to identify, creating a need for an automated and reliable classification system. Therefore, the objective of our project is to develop an AI-based system that accurately classify brain MRI images into four categories: glioma, meningomia, pituitary tumor, and no tumor, using a deep learning model with a GradCam visualization and Flash-based web interface. Scope of the project. Now coming to the scope of the scope of the project is to develop an AI-based system using brain MRI images to classify tumor into glioma, meningomia, pituitary tumor, and no tumor. We use the inspection V3 deep learning model with the GradCam to provide accurate and explainable prediction and implement a Flash-based web application for real-time MRI upload and tumor classification. The target audience include medical professionals, radiologists, hospitals, and healthcare researchers. This project includes the use of brain tumor MRI dataset for brain classification, for tumor classification, training and evaluation of the inspection V3 model with the GradCam visualization, and Flash-based web interface for uploading MRI images and viewing classification results. The exclusions are that no additional dataset are used and there is no real-time clinical diagnosis or direct hospital system integration. In this project, we use a publicly available brain tumor MRI dataset containing MRI scan images organized into four classes. Some limitations include class imbalance in the dataset, the need for medical professional verification, and the high computational resources required for training deep learning models. Methodology. The methodology for brain tumor classification involves deep learning based MRI image analysis and a web based interface for user interaction. It includes data collection, pre processing of MRI images, model development using transfer learning with the inspection V3, front end development using Flask, and integration and testing of the complete system. In this stage, MRI images are collected, pre-processed, resized, normalized, and splitting into training, validation, and the testing set. Then the inspection V3 model is trained for multi-class classification and integrated with GradCam visualization into a Flash-based web interface. This is the architecture diagram of our project. First, the brain tumor MRI dataset is taken and pre-processing like resizing or normalization is performed. Then the processed image are passed to the inspection V3 model with the GradCam for tumor classification. Finally, the results are displayed through Flash-based web application as tumor prediction and visualization. Use case diagram. The use case diagram shows the interaction between the user and an AI system. The user uploads an MRI image, views the prediction result, check the GradCam output, and download the report generated by the system. diagram. The class diagram represents the structure of the system including MRI image pre-processing, inspection V3 model, GradCam module, prediction module, web application and user component. Sequence diagram. The sequence diagram explains the step-by-step process where the user uploads the MRI image, the system pre-processes it, perform prediction using the model, generate a heat map using GradCam and display the final output. Algorithm used. In this project, we used inspection V3 deep convolutional neural network which efficiently extract deep feature from MRI images using multi-scale convolution filters and provide high accuracy for medical image classification. GradCam. We also use GradCam, which is an explainable AI technique that highlights important region in MRI images, influencing the model prediction and helps to identify tumor-affected areas clearly. Hardware and software selection. For hardware, we use a system with a minimum 8 GB RAM, processor support, and optional GPU for faster training. For software, we use a Python, TensorFlow, Keras, Flash framework, OpenCV, Pillow, and Jupyter Notebook for model development and implementation. Implementation. This project is implemented in Python using TensorFlow and Keras. MRI images are pre-processed using OpenCV and Pillow. The trained inspection V3 model is integrated into Flash web application where user can upload MRI images and get classification results along with the confidence scores and GradCam visualization. Importance code segment. This slide shows the important code segment including a library import, data setup and model architecture, model training, model evaluation, GradCam heat map generation, and model saving and loading. This system output include a user interface for patient data entry and an MRI image upload. After analysis, the system display the classification result with confidence code and GradCam tumor localization. It also generates a downloadable medical PDF report. Test cases. We conduct a multiple test cases such as homepage loading, patient detail entry, MRI upload, prediction output, GradCam visualization, and report download. All test cases pass successfully, showing the reliability of the system. Results. This is the confusion matrix of our project and this is a classification report of our project. The result shows the confusion matrix and classification report with an overall model accuracy of 94%, demonstrating strong performance in multi-class brain tumor classification. Conclusion. In conclusion, this project presents an AI-based brain tumor classification system using MRI scan. The inspection V3 model efficiently classify tumors and GradCam provides the visual explanation, making the system accurate, interpretable, and useful for assisting medical professionals in early diagnosis. Future work. In future, we plan to integrate clinical expert feedback, use larger data set, improve model accuracy, and deploy the system on cloud or mobile platform for real-time accessibility. These are the references we are used for our project. This is the VS Code setup for my project. Here, in this collab, I will be import my IPYNB file of my collab project link, and in data set it contains data set of my project. In model it has my developed inspection V3 model in Keras format, and these are the regular like static for images uploadation and generate reports and GradCam using, and here templates. In index.html it contains the HTML code for my user interface asking information, and the result.html it contains the HTML code to display the result of my project, and this is Goody code for my integrating the project to push into GitHub, and this is my app.py, and this is my readme file. These are the requirements.txt. Okay, now I'm going to run my project. Python Android Pie. This is my URL link. I click the follow link. This is the page what I get when I follow the link. Here we are going to fill this form, name, patient name, and age to female, and I choose the file of the brain MRI image and I upload it, and we click analyze MRI. It get analyzing it, and this is the result page. Here it gives that a patient ID generated manually, and it give patient name, age, gender, and it predicts as the meningomia and with the confidence score of 98.67%, and it also include the scan date, and this is a grad cam. Here you can see this is the brain tumor location path. Here it contains three color: blue, yellow, and red. Blue is a less important, yellow is a moderate important, and red is a high important region area. You also download the PDF report like by clicking it. This is the PDF report. We can download it by clicking that. Okay. So this is my project. If you have any queries, you can ask me questions and I'm ready to answer. Thank you.